All right, so today we're going to talk about speed, velocity, and acceleration, how those things are connected, and how they are different. We've talked about them a little bit in past lessons, but we're going to go a little bit more in depth today, and again, talk about their differences and how they are alike. So first, we are going to start with a definition. So velocity is speed with a direction. So you can kind of look at it like we've upgraded speed to give us a direction as well. So like in the picture you see there, the person is going 160 miles per hour, but it doesn't tell us which direction they're going. So that would be a speed. If it had said 160 miles per hour east, that would tell us that it is velocity. So velocity must have a direction. We have to know which direction it's going in order for us to call it velocity. Now, the units for velocity and speed are not always going to be the same. So what we've got happening here is we can have our distance measured in kilometers or miles or meters or centimeters. We can also have our time measured in seconds, hours, minutes, anything like that. So our units can come out to be kilometers per hour, they can come out to be miles per hour, they can be centimeters per second. So the units are very varied. So you always want to pay attention to the units that you're given. We're going to be using the V equals d over t formula to figure out our velocity in this unit. Meaning velocity is equal to distance over time. So when you have distance over time, that's where you get that miles per hour. That's distance in miles per, which is the strike, and then hour. Or you have kilometers per hour or centimeters per second. That's distance over time. Now, if we want to use the triangle, kind of like we used with our force triangle, we can use it the same way. So when you're setting that up, we're going to have D on top, and then V and T on bottom. So remember, if I want to know what V is equal to, I'm going to put my finger over the V, and I will see that it's equal to D over T. If I want to know what D is equal to, I'll put my finger over the D, and that is equal to V times T, because those bottom two get multiplied. And then if I want to know what T is, put my finger over the T, and I see that all I have left is D divided by V. So these are the three forms of this formula. And if you forget them, or if you don't know how to rearrange the formula, then you're going to use the triangle to figure that out, just like I've shown you. So, again, with these units, if you look at I've got two scenarios here. One is meters per second, and one is miles per hour. So each of these has a distance component, which would be the meters or the miles, and they each have a time component. One is measured in seconds, and one is measured in hours. So to get your velocity units, you're going to combine distance over time. So like the first one is meters over seconds. The second one is miles over hours. This one is written as mph, though. We don't use the slash. To get the distance units, you're going to look at the first portion of the velocity unit. To get the time units, you're going to use the second portion. So, for instance, if we have this here, km over hr, we know that the distance is measured in kilometers, and we know that the time is measured in hours. So that's how you get that. Or if you have centimeters per second, you know that your distance is in centimeters and your time is in seconds. So that's how you can grab that information from the units. And then you know exactly what everything's being measured in. So next, we're gonna kind of do a little practice on that. So if we want to know what our speed or our velocity units are going to be, and we know our distance and time units, we can kind of put those together. So like this first one tells us we've got our distance is measured in meters and our time is measured in seconds, so we know that our speed is going to be measured in meters per second. So you take your distance over your time, meters per second. If we know our speed, that's miles per hour, we know our distance is in miles, and our time is going to be hours. Here we've got kilometers per hour, so the distance is kilometers, and the time is hours. And then here you've got centimeters and days, so our speed is going to be centimeters per day. So you just take that distance and you put it over the time in order to find out that answer. So here we're going to use that v equals dt. Oh, go back. So let me bring up my pen. So v equals d over t. How long will a car travel, or will a car traveling 30 miles per hour take to cover 150 miles? So we've got 30 miles per hour, that's a velocity. And we've got a distance. That's 150 miles. So remember, if we go back to that triangle, we're going to have distance on top and then VT on the bottom. So if we're looking for how long, that's a time constraint. So you put your finger over the T, and then all you have left is D over V. So T equals D over V. So T is going to be equal to 150 miles over 30 miles per hour. So 150 divided by 30 is equal to, and I'll give you a second to think about that. That's going to be equal to 5. And our time, we know, is going to be in hours because of this right here. It tells us we're in hours, so that's going to be 5 hours. So it takes us 5 hours to go 150 miles if we're going 30 miles per hour. So this becomes your final answer. So here's our next one. Here we are looking for velocity. And velocity is equal to distance over time. So we don't need to move this formula around at all. We can use it just like it is. So we know the distance equals 1,100 meters, and time is 330 seconds. So we will take distance over time, 1,100 meters over 330 seconds. And we'll calculate that out to be 3.3. Let's try that again. It should be 3.3, and our units are going to be meters and seconds. So that's meters per second. And that becomes our final answer. So that brings us to our acceleration. So acceleration is a measure of change. Remember, we talked about that with our force unit. Acceleration is a change in speed. So it's related to speed, but it's not the exact same. And this tells us how much it's changing per second. So we will have meters per second per second. That's m over s, which is often shortened to m over s squared. So that's meters per second squared. So that's where we get that unit for acceleration. So an acceleration of 5 meters per second squared means you gain 5 meters per second every second. So it's going to change by 5 meters per second each second. And an acceleration of -5 means you lose 5 meters per second every second. So we can have negative acceleration. You've got positive acceleration that's going to push the object forward and go faster, and your negative acceleration is going to cause it to slow down or even change directions. So here's our formula. We've got acceleration is equal to final velocity minus initial velocity over time. So acceleration is in meters per second. You've got your final and your initial velocity. This is going to be your meters per second. And then your time is in seconds. So acceleration is meters per second squared, velocity is meters per second, and time is in seconds. That final velocity is going to be where your object ends. So how fast was it going at the end of the problem? And the initial velocity is how fast is it going at the beginning of the problem. Sometimes the velocity is not outright given to you. It's not going to say 0 meters per second. The question might say something like, the car, which is at rest, speeds up to 50 miles per hour in 8 seconds. What is the acceleration? So you're going to read that problem and realize if it's starting at rest, that initial velocity is going to be 0 meters per second. So it's very important that you read the problems very carefully, because you may not actually be given the number. You may have to infer the number from the question. So like I said, acceleration can be positive or negative. So here we've got an acceleration of 6 meters per second squared and negative 6 meters per second squared. On the positive one, so you notice at 0 seconds, if we're going at 60 meters per second, so that's our starting velocity. So every second, we gain 6 meters per second. We're going 6 meters per second faster. Our velocity is getting faster by 6. So after 1 second, it's 66. After 2 seconds, it's 72. After 3 seconds, we know we're going to add another 6 seconds on there. So that's going to be 78. I'll put that on there. 78 meters per second. Now your negative is going to go the opposite direction. So now we're going to be slowing down. So after 1 second, we're going to be going 6 meters per second slower. So we know we're going to be going 58 meters per second. And then we're going to go 6 meters per second slower again. So 52. And then we're going to lose another 6. So we'll be going 46. And if we keep going and going and going, we find out that it takes 10 seconds to get all the way down to 0. And you can calculate that using the formula that we had on that last page. So let's go ahead and use that formula. I'm going to put it, so A equals VF minus VI, or the change in velocity over time. So this one tells us that we are going from rest to 60 meters per second with an acceleration of 6 meters per second. So how long did it take? So we know that our initial is at rest, so that's a 0. And our final is going to be equal to 60. And then we know our acceleration is 6 meters per second. Now, we want time by itself. So what we're going to do is we're going to take that time, and let me grab my black pen. So we need time by itself. So we're going to multiply both sides by time so that we have A times T equals VF minus VI. And then we need to get that A back over to the other side. So T is going to be equal to VF minus VI over A. So we're going to take 60 minus VI, which is 0, over 6. So that's final velocity minus initial velocity, 60 minus 0, divided by the acceleration, which is 6. So 60 minus 0 is 60, and then 60 divided by 6 is 10. So it will take us 10 seconds to go from rest to 60 meters per second with an acceleration of 6 meters per second. All right, and then this is going to be our last problem here. So a bird accelerates at 4 meters per second squared to 4 meters per second in 5 seconds. What is its initial velocity? So let's write down what we have first. We've got the acceleration is, well, if it'll let me write it, 4 meters per second squared to, and we're going to 40 meters per second in 5 seconds. So we're going to need to move this equation around a little bit because we have A equals VF minus VI over time, and we are looking for initial velocity right here. So first we're going to multiply both sides by time, so we will end up with AT equals VF minus VI. We're going to subtract VF from both sides to move that over, so AT minus VF equals negative VI. And then we want to get rid of that negative, so it's going to make everything on the other side negative. So negative here, let me move some of this. I'm just going to write that final equation right over here. So we will have negative AT minus VF equals VI. So negative 4 times 5 minus 40. So we want to follow PEMDAS. We're going to do everything inside the parentheses first, starting with that multiplication. So 5 times 40 is 20. We'll put that back down here. So negative 20 minus 40 equals VI. And then we've got 20 minus 40 is negative 20, so negative 20. And then we're going to apply that negative inside. So a negative of a negative is a positive, so that means our initial velocity was 20. And that's, let's see, meters per second. I'll put that up here. So 20 meters per second becomes your final velocity. So this does take a little bit of manipulation, moving your variables around, all that sort of thing. But as long as you are following those opposite rules, multiply and divide are opposite, add and subtract are opposite. As long as you're following those rules, you should be just fine. Now, I am available today for any questions you might have. So if you do end up having any questions, email me at tkennedy@garlandisd.net, and I'll be able to get back to you so that you can complete this assignment successfully. So any questions, let me know. If you have me on Remind, you can shoot me a message as well. And my Remind code is up on the board. It's up on that front board. So this assignment for today is due at the end of the period, and I will be grading those as soon as I get back to school, and I will see you guys in the next class period. All right, good luck, guys.